Are we ready to learn about inelastic collisions today? Okay, cool. An inelastic collision is a collision in which there is loss of kinetic energy. While momentum in the system is conserved in an inelastic collision, kinetic energy is not. This is because kinetic energy is been transferred probably to something like sound. So we can give a small example in a toy truck.
In this example, we're going to have two toy trucks colliding to each other and trying to get them to stick. We will be thinking of one of them going as a positive and then the other as a negative. As you can see by the two cars, as soon as they crash into each other, they go into a rest. That would be called a total inelastic collision. In an inelastic collision, the kinetic energy is not conserved. As we can see by the two cars, the kinetic energy is lost by both, making them go to rest. Watching it slowly one more time, we can see that the toy cars are not crushed in any sort of way, so they must change their kinetic energy in another way. I would assume that they would change their kinetic energy into sound. Kinetic energy would most likely be turned into a sound instead of a crush. In a real-life situation, as we can see here, as the two cars crush into each other, that is where their kinetic energy goes to. To give a more visual explanation, I have two graphs up here for each car. Angelica, would you like to take a whack at it?
So in the graph, because the y-axis is distance and the x-axis is time, the slope of the graph is going to be velocity, right?
That's correct. We usually use our distance and time graph so we can figure out our velocity. And now that we have our velocity, we can start moving into our momentum and our energy.
Okay, so do we know the equation that we must use for our momentum?
Let's just continue. The two equations that we would be using are our kinetic energy equation and our momentum equation. As you can see, we did get the mass and our velocity for our two cars. We will use this to determine our inelastic collision. We would first determine our kinetic energy. We can see that the total kinetic energy is equal to the kinetic energy of car 1 plus the kinetic energy of car 2. The equation for kinetic energy is 1/2 times mass times velocity to the second. Once we plug in our numbers, we can see that our kinetic energy total is 0.098 joules. Now, to determine if our collision was inelastic, we must find the kinetic energy final. If the kinetic energy final is equal to 0, then we might have an inelastic collision. As we work on our kinetic final, we work on it just like we do our kinetic total, finding out our kinetic energy for our first car and our kinetic energy for our second car. As we plug those numbers in and changing the velocities to being 0, our kinetic energy would equal 0. Since the two kinetic energies do not equal each other, we can determine that kinetic energy is not conserved in this inelastic collision.
What about momentum? Isn't that supposed to be conserved?
Yes, Julia, I'm getting there. Okay, now let's move on to momentum. Momentum in an inelastic collision is supposed to be conserved, but sadly we do not live in a perfect world, so our lab is not as perfect as can be. Since we did use our mass and our velocities that we had gained, we do have a different initial momentum. The initial momentum did not equal 0. It's a little bit too far in the negative side because we did see a little bit of a bump when they collided. But if this was in a perfect world, our initial velocity would have equaled the same as our final velocity. Our system was a little bit small, but in a real-life situation with the two cars colliding to each other in an inelastic collision, the momentum would be initially 0 because of the two velocities of the car would cancel each other out because of one going the opposite direction, causing their velocity to be negative from the other car. Now to conclude our lesson for the day, as we can tell that kinetic energy and an inelastic collision are very connected. With our kinetic energy, we can see that in this collision, the energy turns into something else, whether that is heat, whether that is light, whether that is sound, or whether it's just a conform of two different cars. And of course, when it comes to an inelastic collision, momentum is conserved.
Well, that is all that we have for today's lesson. I'm glad that we all learned something today. What about you, students?
I do kind of get it.
Yeah, it does make sense now. Three.
Elastic collision is.
Look that up. This thing is
Is a collision in which no kinetic energy is lost. Well, correct. Anyways, we will be using the, what are the equations called?